All right, so here we're going to take our scutoid and try to make its length adjustable. I don't think I'll need to change anything about the actual pentagon and hexagon shapes except their location. So let's actually set that at the beginning here. So let's set scutoid length equal to, let's start it out with 1 so that we can recreate our original one. So this is the length of the scutoid along its prism. There we go. Or prism axis. Is that what you call it? Maybe? I don't know. All right. So the first thing I need to change is this here. So this needs to become a negative SC length. Actually, I'm going to just copy SC length so I don't have to keep typing it. Then this needs to become a negative SC length. So basically, I'm looking for wherever I've assumed that the length is 1. That doesn't change anything about the hex. Let's see here. We come down to the 4-edged sides. Okay, so these ones here need to become SC length, SC length, SC length, SC length. I could multiply the zeros by SC length, but that won't do me any good. Let's see, we come down here. I've got a -1 in the Z direction, so that needs to be an SC length. Here I'll have a -1 in the, or negative SC length, negative SC length. I don't believe I need any others there. Okay, here for my extrusion path, I need these to be negative SC length. There we go. All right, come down to this extrusion. This is just the bottom of the thing. Okay, so that SC length is already encoded here. All right, so come over here. This -1 needs to become an SC length. So I need to keep an eye out for 1s and 1/2s because those are where we're assuming that the length is 1, or the depth, the height, I don't know, whichever name makes more sense to you. Let's see. Once I realized that length, width, and height were interchangeable in the volume equation, I stopped worrying about what the difference between them was. So here we've got a half because we're going along the triangle. So this needs to be half of SC length, and this needs to be half of SC length. Okay. Let's see here. I've got 1 minus H width. Yes, that does need to be an SC length. H width, H height, that ought to be fine. Oh, I got a -1/2 here. Multiply that by SC length. The good news is everything is color-coded, so if I do make a mistake or if I leave something out, I should be able to tell which shape is giving me the problem. All right, I think that takes care of it there. Now we move on to the hard part. I don't have any assumptions here about what the depth is. Here I do, so that becomes an SC length, 0.5 times SC length. And then we'll make an SC length here. Right, nothing there, nothing here, nothing there, and this becomes that. And here, one last one, SC length plus side thickness. Okay, let's give it a whirl. Control-2. Ooh, I got back the same shape. Wow, that actually, well, it hasn't given me a problem yet. I'm not going to say it's worked. That did give me back the same shape. Okay, now for the moment of truth. Let's double the side length, the scutoid length. Control-2. Repeated points, invalid edge. Oh, goodness. That did not work. That did not work at all. Okay, well, I don't have a problem quite everywhere. The good news is I have the correct separation between these two, because that looks like a length of 2. The problem is my blue has everything is extending too far. Okay, actually, hang on a sec. These things went the correct distance this way. They're just going too far this way for some reason. Oh, you know what happened, I think, with those? I don't want this to be... This is still being treated as a square. Oops, oops, oops. Okay. So this is still being treated as a square. So let's think about this. So I need for the... I guess let's just try changing the x's back and see if that fixes this part. Control-2. Okay, yes, I know there's a problem. I'm not interested in that problem. Okay, I need to change the others. So I leave the x's like that. I change the y's to a 1. I'm doing trial and error here because I don't really remember which edge corresponded to which. Okay, good. We've got it set up so far. We've got the cradle made right now. Okay. So I zigged when I should have zagged. Okay, so I need to adjust some of these. Oh yeah, this doesn't need to scale with that. Okay, I was a bit overzealous there. Okay, cool. So I've fixed the easy sides. Now I need to fix the difficult side. Actually, based on my previous experience, I think I know what I need to do. All right, cool. We've got 5 of the 8 sides together, right? Because this thing is 1, 2, 3, 4, 5, 6, 7, 8. I've got 7 of the 8 sides together. Now I just have to change this thing's origin, basically. Maybe I only have to move this by half the side length. Excuse me, over here is what I'm thinking. Cool, there we go. Ooh, I've got an elongated scutoid. All right, let's double check this now. Let's change this to 3. You know what? Let's make it interesting. 3.14. Go big or go home, right? Okay, that's still not working there. Let me see here. Oh, you know what? I had it multiplied by 2, and then I'm divided by half. Maybe is it possible I don't need the SC length there? Control 2. And there you have it, folks. We've got a scutoid of length pi. That worked out. Let's try 2 pi. 6.28. Actually, let's make it for real. 2 times pi. There we go. And there we have it. We have a scutoid that works. Oh, man. So the only other thing that we might do with this would be to change the fraction that this triangle takes up. How difficult would that be? Because that only affects the last 3 parts. And it really only affects these halves here. You know what? I'm going to give it a try. All right, let's have split frac equal to 0.5. This is the fraction of the scutoid. There's probably a technical term for this. This is the fraction of the scutoid where the triangle occurs. There we go. All right, so let's go down to the triangle here. Okay, so what did I call that thing? Split frac. Okay. I should, we all know what happened last time I said that, just have to replace the halves with this. So I replace this half with split frac. Okay, no, I don't replace all the halves because some of those halves are cutting the hexagon length in half. Right. So that shouldn't affect these because these aren't going along that direction. So I've got these here. This shouldn't be impacted by that. But this 0.5 times a scutoid length should be the split frac. Okay, I think it's everywhere I have a half times a scutoid length, right? Yell at me if I'm wrong, please. Let me just do a quick search for other instances of 1/2. Those are fine. Side list, those are fine. That's fine. That's fine. That's fine. Okay, cool. Let's hit Control 2. Okay, so that worked. That kept it there. Let's try taking up, let's say the triangle is bigger, 3/4 of the scutoid. Oh, and there it went. There it happened. We've got the triangle going up. It worked. Let's try adjusting both of them. Let's say, let's make this one 1.67, and let's make this one 1/3. Let's do Control 2. And there we have it. We have a nice adjustable scutoid. The only other thing I need to do, and I forgot to do this in the original code, is make something called scutoid equals compound of all the sides. So let's see, what have I called everything? Oops, I skipped 4 and 5. Okay, well, there you go. We'll say that pent and hex are the sides 4 and sides 5. So when I hit Control 2, it should compound those. Compound takes, oh, excuse me. That needs to be in a list. Open bracket, close bracket. Control 2. All right, there we go. Now we can move that around. We can do anything we want to it with our compound function. This has been a fun project. I hope this is useful to you if you're studying scutoids or want to use them in your class. This is a not a necessarily quick way, but all you have to do is, for you it's quick. For me it took a few hours. You can just copy and paste this code and use it for whatever kind of scutoiding you want. Thank you so much for watching. I will see you next time. Bye-bye.